Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Fischer esterification under acidic conditions, dry HCl gas with ethanol. The starting material is RO-CH2-CO2H, which is an alpha-alkoxy acetic acid containing an ether linkage, RO- and a carboxylic acid group, CO2H. Moving on to the next step. Identify the reactive functional group. The carboxylic acid, CO2H, is the group that undergoes esterification with ethanol under acid catalysis, dry HCl. The ether linkage, RO-CH2, is generally not reactive under simple Fischer esterification conditions. Moving on to the next step. Reaction with ETOH dry HCl. The carboxylic acid reacts with ethanol via Fischer esterification, CO2H plus ETOH, CO2H plus H2O. The RO ether group on the other side of the molecule remains intact because simple ethers are not cleaved under these mild acid conditions. Dry HCl gas in the presence of ETOH is not strongly nucleophilic enough to cleave a simple alkyl ether under these conditions. Ether cleavage typically requires concentrated high or HBr at high temperatures. And for the final step, evaluate the product. The ester formed is RO-CH2-CO2H, where the ether oxygen still bears the R group and the carboxylate is now an ethyl ester. This corresponds to option B. Option A, RO-CH2-CO2R. This would require the carboxylic acid to esterify with RO, not ethanol, which is not present. Option C, ETO-CH2-CO2H. This would require both the ether RO to be replaced by ETO and esterification. Ether cleavage and reetherification does not occur under simple dry HCl ETOH conditions. Option D, ROC is equal to O-OH. This is a carbonate ester, which is not the product of simple Fischer esterification of an alpha-alkoxy acid. Therefore, the correct answer is B. Therefore, the correct answer is option B.